Let's go to 4a. This about normal distribution. Let's go over this calculator program. We are looking for probability, then you use normal CDF. When you're looking for that K, probability X greater than K or less than K, this K, then you got to use inverse normal. When you're looking for this mu, mean or standard deviation, you still use this, but you have to use a Z-curve. Z-curve means that's normal distribution. You have a mean as a 0 and a 1 as a standard deviation. Then you got to use this formula. X minus mu over sigma equals Z to figure out the mean and standard deviation. Also remember, when you put into the calculator the probability, you make sure it's X less than K. Any probability you put into the calculator automatically recognized as X less than or equal to or less than K. Therefore, for 4a, we're looking for the probability. You have to use this normal continuous data frequency. That's number 2. We got mean equals 65 and standard deviation equals 5. For the probability, I'm looking for less than 61. Now we put into calculator. We put into the normal CDF because we're looking for the probability. Then we put the lower bound is negative 1e99. That basically means negative infinity to 61. And mu equals 65, standard deviation equals 5, then your answer will be 0.212. Now let's go to 4b. In a training section, there are 40 basketball players. Find the expected number of players with a weight less than 60 kilograms in this training section. Expected number basically means the total number times your probability. Therefore, you will use 40 times 0.212. You will get 8.48. Even players should be natural number, but since it's the expected number of players, we could have this decimal. For 4c, the probability that a basketball player has a weight that is within 1.5 standard deviation of the mean is Q. Sketch a normal curve to represent this probability. This mu plus 1.5 standard deviation, or this mu minus 1.5 standard deviation. Then we plug in mu equals 65 plus 1.5 times 5. That's 72.5. 65 minus 1.5 times 5, you got 57.5. When you sketch this normal distribution, show mean it's 65. Then you add standard deviation, that's 70, 75, and 80. For this side, you have 60, 55, and 50. So you will label 57.5 and 72.5. We shaded this area. This will be Q. For D, find the value of Q. According to the foreseen probability, this X between 57.5 to 72.5, that's a Q. So we got to use the normal CDF, lower bound 57.5, upper 72.5. The mean is 65, standard deviation is 5. Then this will be the answer. So Q equals 0.866. Let's go to 4E. Given that P weight greater than K equals 0.225, find the K. Since I'm looking for this K, you have to use inverse normal. For the inverse normal, this area, make sure it's always we do X less than or equal to K. For given information, we got the W greater than K. So you have to work out that W less than K or equal to K equals 1 minus 0.225. You don't have to work this out. You can let calculator work out for you. So for area, that will be the probability. We put in 1 minus 0.225. The mean is still 65. Standard deviation is 5. Then inverse normal, you will get this. That is K equals 68.8. When you're working out this K, remember this area always we put in the probability of X less than or equal to K. For 4F, a basketball coach observed 60 of her players to determine whether their performance and their weight were independent of each other. Her observations were recorded as shown in the table. She decided to conduct a Chi test for independence at the 5% significance level. For this test, state the null hypothesis. H0, we have performance and weight. So we say performance and weight are independent. Compared to no hypothesis, we have alternative hypothesis H1. If ask you about alternative hypothesis statement H1, you will say performance and weight are not independent. For 4G, for this test, find the p-value. So we put the table into this matrices, 3 rows and 2 columns. Then we go to chi-square test. You will get the p 0.287. 0.287. Then you need to compare this p with the 5% significance level. Since this p greater than 0.05, significance level. As we know, this shaded area we call rejection H0 area. The area means probability significance level 0.05 for this problem. Since your p-value is greater than 0.05, means it will fall into this area. Means we don't reject H0. In other words, performance and weight are independent. When you compare P with the significance level, if greater than this area, means they will fall on outside of this area. If less than this area, they will fall into this rejection area. Let's go to 5A. According to this information, this event follows an norm distribution. We know the mean equals 400. Standard deviation equals 50. I'm looking for the probability that X is greater than 400. Since we're looking for the probability, we need to go to normal CDF. For normal CDF, lower you will put the 400. And upper one, you got to put the 1E99. That stands for positive infinity. Mean is 400. Standard deviation is 50. Then you keep putting enter. Then you will get 0.5. Now let's go to 5B. A farmer labels one of these corn cobs as a premium. If its mass is greater than 8 grams, 25% of these corn cobs are labeled as a premium. Find the value of A. According to the given information, we can write down that probability this X greater than A equals 0.25. We're looking for this A. So we got to use the inverse normal. Please remember, when you put into calculator this probability, make sure this part is less than. Therefore, I will turn it into probability X less than or equal to A equals 1 minus 0.25. That is 0.75. Now we put into calculator, that's inverse norm. Area will be 1 minus 0.25. Make sure when you put in it's always less than or equal to this K. Mean 400, standard deviation is 50. So we get this A equals 434. For 5C, estimate the interquartile range of this distribution. We know the first quartile, that's 25%. The third quartile, that's 75%. This is 0.25. This is 0.75. Therefore, you need to figure out that K value. We use inverse normal. For area, we put 1 minus 0.25. we already got the third quartile, that's 434. For the first quartile, we put the area that is 0.25. We got 366. Therefore, for interquartile range, we use IQR stand for that, equals the third quartile minus the first quartile. We plug in, get 434 minus 366. So answer is 68. For 6A, this is still normal distribution. We have a mean, that's 67. We have standard deviation is 3.4. Then you need to sketch a diagram of this normal distribution. See the region representing the probability the speed of vehicle is between 60 and 70. Middle, that's 67. Then keep adding that 3.4 and minus 3.4. So you can sketch this normal distribution. For 60, it will be here. And 70, that will be here. Then we shade this area. This will be the probability when x between 60 and 70. For 6B, we are looking for the probability. So go to normal CDF. Here's all answers and how you put it into the calculator. You can check by yourself. For 6C, it's found that 90% of the vehicle are exceeding the speed limit as kilometers per hour. Find the value of this s, correct to the nearest integers. We can write down that this x greater than s equals 0.19. We got to use the inverse normal. And also remember, we need to put into calculator that's x less than or equal to s, 1 minus 0.19. When you put into calculator, you will get this s equals 70.0. Remember, we need 3 significant figures. For 6D, there is a fine of $65 for exceeding the speed limit. And one day, the value of fines issued was $14,820. Number 1, calculate the number of fines that were issued on this day. So we do division, get the 228. For number 2, estimate the total number of vehicles that passed the speed camera on this road on this day. First of all, we know that 19% of vehicles are exceeding the speed limit. Altogether, we have X vehicles passed the speed camera that day. We multiply by 0.19 equals 228. Then we divide it by 0.19 both sides. So you x equals 1200. For 7A, a factory makes metal bars. Their lengths are assumed to be normal distribution with the mean 180, and the standard deviation is 5. On the following diagram, see the region representing the probability a metal bar chosen at random we have length less than 175. We know the mean is 180. So we're looking for less than 175. It will be here. This area, that's the probability. Label here is 175. Try to add 3 sigma here, but you don't have to label. And subtract 3 sigma. Then estimate. Since the mu equals 180 and standard deviation equals 5, this will be 175. Then you shaded this area because it's a less than. For 7b, a metal bar is chosen at random. The probability that the length of a metal bar is less than 175 is equal to the probability that the length is greater than h centimeters. Write down the value of h. According to the given information, we know that this x less than 75 equals p, here's x greater than h. As we know, the normal distribution graph is symmetric. If here is 175, we have distance 5. Then this part, we have distance 5. That's 185. This will be the same area. Therefore, this h equals 185. For 7b2, find the probability that the length of the metal bar is greater than 1 standard deviation above the mean. We know mean is 180. Standard deviation is 5. Therefore, px greater than 185 equals, we put into calculator. Put into normal CDF, and lower bound is 185, upper is infinity. We use 1e99 to stand for that. 180 and 5. You will get 0.159. Number 8a. Daniel grows apples and chooses at random a sample of 100 apples from his harvest. It forms the distribution of diameter.